Compound 1 is heated, a product C14H20 is isolated. Give us a structure for the product and an error formalism for its formation. Well, the first thing we can do here is we can look at the formula for the product as well as the reactant. So the reactant has 5, 6, 7 carbons and the product has 14 carbons. How could it have that many more carbons? If you notice, 7 times 2 is 14, so it probably used 2 of these molecules. It also says that it was heated. And we can also notice that this is double, single, double bond, so it's a conjugated diene. And with all of that information, we can conclude that this is a Diels-Alder reaction because we have double, single, double, a diene, and then we will have a dienophile, which will be just one double bond from another molecule of itself. Let's just take a look to see what it would look like. So I'm going to redraw this. And then I'm going to draw this. Let me just draw it this way. This is how I'm going to orient it to make it easier for me to do the Diels-Alder reaction. So you can notice that from one molecule of our starting reactant, we can have the diene, double, single, double, and another molecule can provide the dienophile, which is a double bond. And when we get the two molecules together to do the Diels-Alder reaction, we will get 7 plus 7 carbons. It will be 14 carbons. Now, how would we predict the product? So the first thing I do is I draw my Diels-Alder prototype. This is it. And I can even number it. This is how I number it, this way. And then I can draw my arrows like this. So this is a concerted reactions. It has 3 arrows. And the product of a Diels-Alder is a cyclohexene. 1, 2, 3, 4, 5, and 6. And you can see that I already oriented my molecules in such a way to imitate the prototype that I have drawn. And now I can go ahead and I can do the reaction. If you want, you can number it as well. 1, 2, 3, 4, 5, 6. And I can go ahead and do my arrows. They could be clockwise or counterclockwise. It wouldn't matter. And what we will get, if you want, what you can do, there are multiple ways to do this. One way is to just redraw this and to follow the arrows, which is a good way to do that also. Or you can just draw the product, which is a cyclohexene, and see what carbons are missing, what is attached to what. So I guess we can just draw the product and we can number it. It's a cyclohexene. Now there's a bond between 4 and 5, and now I'm going to look at this molecule and see what I am missing. So I can see that my 4 and 5 are connected to the cyclopropane, like this. And I can also see that my carbon number 2 here is connected to another cyclopropane, like that. And the carbon next to 2, so this carbon has a double bond. And if you calculate the number of carbons and the number of hydrogens, it should give you the correct formula. And therefore, this should be my correct product for the Diels-Alder reaction that is given in this question. I hope you found this video helpful. This is Maya from Transformation Tutoring, and I look forward to seeing you in more of my general chemistry and organic chemistry videos.